probably 8 years ago in about a week's time, and we were speaking at that time to about 20 people. So the fact that I'm even here talking to you as a manufacturing engineer, not as a construction engineer, with no construction background whatsoever, is a sign that times are changing. And Jamie said that we argue, and I'd say we debate. Maybe we do argue because we're so passionate about what we do. And I would say I'm Jamie's yin and he's my yang. I wear a tie because I'm an engineer, and Jamie doesn't because he's an architect. And the thing about manufacturing engineers, we're a strange bunch. And normally, I would hope you never see us. If people design their products well, our job is just converting those designs through a factory into products that people use. If we get our jobs right, those products are perfect. They always work. They never fail. But we have come out of our shell. And I used to have a boss who worked for Toyota. And he was involved in one of the first projects where the people on the shop floor, the manufacturing engineers and the technicians, were given the power to say, I am not going to make that product. And what you're going to see from me is quite a pokey, spiky mark, because unfortunately that's who I am. But take me with a pinch of salt that we all have the best interests of the industry at heart. But I've got to play that role of, as technicians, as builders, we shouldn't take it anymore. People damage their bodies building our buildings. And I wouldn't want to do it, and I wouldn't want my son or my wife to do it. So we have a role to change what is built in our environment. The last thing I'm going to talk about before I go into the presentation is what is a platform. And the reason Jamie and I argue is we don't know. And we've got opinions of what a platform might be. But actually, I argue with myself over what a platform for construction might be. So it's not surprising that the two of us argue about it, which means that all of us could argue all day long. We could argue for the whole course of this program and not get anywhere. And the example of the shipping containers is a great example about where a compromise was achieved. And actually, is the shipping container the right size? Probably not. Could it be improved? Probably. But the fact it was standardised and the whole industry worked to that standard absolutely transformed, as Jamie said, the whole logistics and the way that we live. And people use the automotive industry as an example of platforms. And one of the first adverts I remember for a car when I was a kid was for the Mazda 626. And I remember they used the slogan, it was a car built without compromise. So going back to Keith's slide, that means it was free. It got an infinite fuel economy. It could carry all the people you would ever want to carry at 200 miles an hour. And in reality, we just know that's not true. So our job on our design for Sigma is to find that compromise and to try not to argue and bicker over the finest details here and there. Because if we can compromise and standardise on something, we will already be a step ahead of where we should be. So I'm going to talk about a few things. The first thing is Moby, talk about why you should enter, what is in the schedule and the programme, and then how you enter. Now, the Moby competition is really interesting, and I realised that actually we are funding a platform development through the hub already. Moby is a charity run by George Clark, and we've run a competition for 11 to 24-year-olds to design a house of the future for multi-generational living. And what we did is, to make this competition accessible for kids, we designed it around a sort of a Minecraft mentality, and around 3 metre by 3 metre by 3 metre cubes that they could stack and orient and do different configurations. Now, actually, that is a platform. And what some 11 to 24-year-olds have come up with will put Jamie to shame, I would suggest. They were given this as a briefing. This is all they had, and the team who won designed this house. So this was designed by 16-year-olds. And their level of thinking has gone as far as saying, I don't need a garage anymore, but what I do want to do is have my charging post for my electric car covered so that I don't get wet when I plug my car into charge. They've thought about how it can be renewable and using solar and bioenergy to heat the house. They've thought about how can they run the MEP within the structure so that rather than building nice walls and then chiseling them out to run power cables through and plumbing through, it's all built into the structure already. They've thought about how can they compromise on space? How can I make my dining table a piece of art? How can I recess my radiators into the walls so that they take up less room? And this is 16-year-olds. When we look at the people who are at the top end of that age spectrum, this chap has broken down his cubes into subcubes that he can use to build up the structure, and into subcubes again, such that he can plan his furniture within the structure. So whenever he has a space that is 2 cubes wide, he knows how many mini cubes it is, and therefore what the different configurations for furniture could be within that space, which means you, as a customer, can pick your configuration and you know it will work. He then realised that if he can control the tolerance on this, he can launch the manufacture of that furniture just in time. So that rather than being where we are now, where we build a house and then fit a kitchen into it, you can build your building and just assemble all of your furniture into it and you know it's going to fit. The last design that they came up with, again, they had to show multi-generational living, and they came up with this concept of a starter house, which was a 1-bedroom house. They realised that for adding 2 more modules stacked on top of each other, they could then turn it into a 2-bedroom house with a bigger kitchen and a bigger living area. So, again, being pokey, this is 16 to 20-odd-year-olds. This is what you have to compete with. And these kids are the future of what we will all be living in and using in the future. Now, what does that mean for the CIH and what does it mean for me as a manufacturing engineer? I've now got a job to try and work out how I can make this a reality. So we are doing technical work where we're looking at how we can use robotics and automation to stack these cubes. And are there robots that are accurate enough? Can they carry the payload? Can we do the stressing on these features such they're not craned anymore, but they're cantilevered out? Can we use the shipping connectors that Jamie talked about so that we can use all of the IP that is already available through the transport and logistics rather than having to reinvent it? Now that is a compromise, but it's a compromise that's got a whole financial backing behind it. So we're already doing platforms, but this competition is about a different one. And before I started, I want to say why you should enter. Now, I said I'm a manufacturing engineer, I'm not from construction. I have worked in the aero industry, I've worked in nuclear, I've done a little bit of work on shipbuilding, I've worked on fuel cells. And what I can tell you is that all the industries that I've ever worked with have moved from being product focused to being process focused. And there is this swing. In a product focused world, you're worried about every project. Every product is different. You design it and then you establish how you're going to make it. You're really reliant on the skills of the people who are going to make it for you. Now what that means is that the output quality is dependent on the people who built it. And you've kind of got this do my job and move on approach. You move on to the next contract, the next project. In process-driven industries, every product is made using the same process. Now whether that's a kit of parts or whether it's a platform or whatever, you just design for the same process. Before you start, you already say, I know how I'm going to make it. And the automotive industry, as far as I'm concerned as a manufacturing engineer, every car is identical. They might change the colour, the shape, but they are all made the same way every single time. And interestingly, that's why I don't work in auto, because it's quite a boring place to work as a manufacturing engineer. In this example, the quality is dependent on the design, so you move a lot of your effort into the design rather than the make. And it's usually really good if you've got a fixed team working in a fixed location. And this is where Jamie and I, you'll start to see us debating with each other. But off-site manufacture, fixed location, people always working in one factory, always going to work 8 in the morning and leaving at 4:30, always being there to give their kids their evening meal and tuck them into bed, which covers some of the social changes that Keith's talked about. So this list is why you should enter. So a passionate call from me. I believe that collaboration drives innovation. If you can compromise and if you can look somebody in the eye and say, I'm going to detune my bit because I realise the benefit it's going to give to you. If you form strategic partners, you ensure consistency of demand and you actually you start to control how often people buy your product. The automotive industry have taken this to the extreme. If you look at the way that people buy cars nowadays, you don't own the asset. Most people get them on PCP. Now what that means is the automotive industry know that every 3 years you're going to replace your car. And the strategic partners that they partner with know that they will sell more fuel pumps and more tyres and more wheels and more suspension. But if they didn't have that approach, that would never happen. Product and component focus rather than trade focus. So again, it comes down to your design and getting those products right. And when we go around the workshop, you'll see an example of where we, as the MTC, have designed a product and it's more expensive. And you'll say, well, why would I ever want something that's more expensive? Hopefully, when you see me this afternoon, you'll go, no, I get it, I get that, that's good. Often, in this world, you increase the value and you move from being a commodity company that can be competed against others into being a service company who make more money. Last one is reduced time risk to market. Now, there are some that are specific to the CIH, and I would go back to the automotive industry as an example. When VW launched their B-class platform, they have lots of different platforms. So they'll have a small city car, a medium one, a family saloon, an SUV, a sports car. And that platform isn't there to do everything, but they bound it and they say it's just to do this one job. And I believe what we are doing with Jamie is coming up with this platform that's only going to do one of those jobs. So we're not trying to do, you know, the 12-storey inner city school. It is just the commodity, the dull stuff. Now, with the automotive example, when VW launched their B-Series platform, they'll identify their strategic partners. So let's say they use Bosch for their fuel system. Now, Bosch will pay for their own R&D. VW won't pay Bosch. Bosch will pay for it themselves. And part of the reason they'll do that is that they know that they will be part of a development and validation program. So when that car is cold tested in the Arctic and crash tested and hot tested in Arizona, it's their product that's being tested, which means that when a car is leased or sold by VW, nobody can spec swap and change a Bosch fuel pump for a Denso fuel pump because it hasn't been validated as part of that testing. Now, what you've got the opportunity to be as part of the hub, Keith has talked about the size of the prize. The CIH is going to be giving you that platform, another use of platform, but the opportunity to test and validate your products as part of a bigger system, which means that you will get locked in. Other people can come in and compete, and using the car example, you can buy cheap Chinese knockoff fuel pumps, but if you put one on your car, VW will not honour your warranty anymore. And you have no real assurance that it's going to work, you're kind of hoping. Now, the last one is the link to the Innovate UK open call. So we are not going to pay people to be part of the platform. We are giving people the opportunity, and we are building the building, we're doing the validation, we're going to work with BRE. I'm supporting with manufacturing expertise and design for manufacture and design for equipment. But with the Innovate UK open call, what we're hoping is if somebody says, well, I've got a near to market idea, but I do need some R&D investment into it, you've got a great case to put in a compelling bid into that call, and you will get the backing from the people in the team. So the schedule and the process. So we've got the briefing event today, the open call will open. We'll close the call later this year, and we're hoping to do a Dragon's Den type approach. And it's not so much selecting winners, it's selecting consortia of people who we can think will make a great band, who are going to produce good music together and aren't just going to be soloists playing their instruments over the top of each other. We will then form collaborative teams, and we're hoping that those teams will be mentored both by an architect working with Jamie and from somebody from my team, so a manufacturing engineering expert. The timeline looks like this. So the open call will run to the end of the year. We'll have a traditional design, make, test, this isn't construction, design, make, test program. We're going to produce a prototype building, not the first one that people use. We then want to assemble that building in 2021. Now, over the course of this event, there are all these workshops, and one of the benefits of entering, I really want to give the people who go into this competition the equivalent of a manufacturing engineering master's degree. So in month one, we might train you on design for manufacture. We might train you on geometric dimensioning and tolerancing. designed for robotics and automation. Get someone like Chris, my colleague at the back, to talk about measurement and metrology and dimensional control. So not only are you getting this opportunity to have these barriers to entry, you're also going to be invested in by us to make you better at understanding this platform world. So to enter, you saw Henry's contacts there, the registration address is there. There is still some work that we don't know at the moment, and I'll come on to that in a second in terms of the down selection. But it is anticipated you will pitch to us and say, I want to be part of this competition. Now, I had to think about what does good look like? What does an entrant give us, I think, that'll work? And this is a great example that I would really like to see at this Dragon's Den pitching. Somebody has come with a load of different people who make materials. You know, they make insulation and glass and breather systems. You've got some manufacturing technology companies. So here we've got laser cutting, we've got self-pierce riveting and adhesive structural bonding. We've gone and found our student, decided to poach him from his university degree at the end of his degree to get his structural engineering thinking. We've got JCB who've said, well, we'll design a new machine that can handle these things and assemble them on site. We've worked with robotic companies. We've looked at future technologies, for example, MEP. How do we stop using twin and earth and start having pre-configured connected wiring and plumbing systems? Who is going to make this? So when we're making our prototype building, who is going to have a factory that employs people that has this kit, who is going to manufacture this? So if you haven't got that, if you've just got a good idea, we've got nowhere to make it. And the last one is who's going to integrate it on site and do the on-site assurance, quality assurance, and ultimately earn the liability. Now, alongside that, there's the what does good look like, and there are a couple of these that are greyed out, and I got them from John. I don't know why they're greyed out. Do you know why they're greyed out?
Sorry, they're originally greyed out because they referred specifically to the active building standard.
Right, okay. But John and I are busy working with the team to try and look at what are these top-level metrics. And I've been saying to our engineers, everything that we do should touch one of these. So we either need to be making it with a reduced whole life cost, or reduced delivery time, or reduced greenhouse gas, or improved productivity. And when you go round, when they're presenting to you, I really hope you can see that as people are presenting. But for your bids, I'd really want you to be saying, we've got this solution, and this is why. We anticipate it to be 50% faster. We think it's going to have a 30% through life reduction. It only needs 20 people rather than 100 people to assemble it. It's ethical, so we're not just going to China and buying Chinese slate that's been mined in unethical conditions. We've come up with a different approach. The review process is the bit I think we still need help. So we need suitably qualified and experienced people who can help us look at these consortia and be really independent. You know, for this, Jamie isn't wearing a Bryden Wood hat, and I'm not really wearing an MTC hat. I will be saying, what is the best compromise? And we need a group of people to help form that compromise. So if anyone knows anyone who wants to do it, come and have a chat with us and we can try and get you involved. So that is everything on the platform that I was asked to talk about. The last thing that I will cover is what we are doing here at the MTC. And you're about to go on a tour, so I wanted to give you a flavour of what you're about to see. Now, when we started the CIH programme, I was given quite a difficult job, which was I was given a quarter of all of the MTC shop floor space that had taken us 8 years to fill, and told to try and work out what kit we should put in it to support construction in about 3 to 6 months. So I had a bit of a panic, and then when I'd settled down, I realised that we had quite a lot of the information around us, and this is the solution that we've come up with. So this hall, you will be coming through some doors here. The hall's about 70 metres long and about 30 metres wide. And what we've done is we have looked at our technology roadmap. We've looked at a lot of our members' and customers' technology roadmaps. We've looked at other people who are doing R&D. So one of those groups is here, Construction Innovation Centre Scotland, who've got some really clever timber thinking. So there was no point in us doing anything with timber because they're way ahead of us. But what we have gone out and bought, which is not all here yet, it'll be here by the end of the year, This is a really, really big laser cutter. So that laser cutter is going to have a bed of 12 metres by 4 metres. We've picked 12 by 4 because that's how big you can get on the back of a lorry. So there's no point in going any bigger than that. We picked laser cutting because I know it works. We use it all the time in the aero industry and in the automotive industry. So how can we introduce that technology to construction? And one of the examples out on the shop floor, I hope, will make you realise why you might want it. We've got our mobile robotic fabrication cell. And again, for those who were here last year, you'll have seen it before, but the challenge there is don't use robots to do things like bricklaying. Bricks are designed for a person to hold in one hand. Robots are really good at different things. They're good at holding very, very big, heavy structures. So if you want to use a robot, design your part to be robotically handled. Don't try and pick up a brick. And the example out there you'll see gives a good indication of what you might do differently. This area is all about fabrication. So Jamie's brackets that he showed, these little coloured brackets, are a great example. And we've got a bit of kit in there that we developed as part of an Innovate UK project. And just to give you a bit more information about that, the challenge was we went to a small fabrication company and said, why don't you use robots? Why don't you use robotic welding? And they said, because it takes us so long to program them, if we're only making 10 brackets, there's no point. We may as well do them by hand. So what we realised, the problem wasn't the robot, it wasn't the welding, it was how do you do a CAD-CAM link-up so that when somebody designs it, the program is automatically sent to the robot. So one of the cells that we'll have in there does that robotic programming automatically. So it's introducing CAD-CAM to the construction industry. So we'll be making small brackets, that sort of thing down there. And we've got our big Google gantry robot, number 6, and that's where we envisage that we will be doing automated pick and place of MEP systems. And anyone who's been around and seen our electronics line, what we will be doing is, like our electronics line, picking up components and sticking them down, but on a 12 metre by 4 metre scale. But the approach is very similar. So it's not new, it's been proven just on different stuff. Our parallel kinematic robot is all about machining and how can we do quite accurate machining. And when I was out looking at the machines that we could buy, one thing I realised, and I've seen that some machining companies, they all machine their components flat. Now what that means actually is only the floor and the ceiling are in that orientation. All of your walls, where you've actually got your doors and your cable run-throughs, are all in the other plane. So why are we machining them flat? Why aren't we doing them side on? Because that's what we do when we machine aerostructures and wings. It also takes up less floor space, by the way, so that's why we've kept that bit of kit. Down at the bottom end of the hall, we've got all of our on-site or near-to-site assembly. And again, we don't know what the solution is. So we've gone out and bought the biggest commercial robot that you can buy, biggest in the world, because if you design for any bigger than that, you can't do it. The kit doesn't exist. We've also bought a JCB, Hydrodig, which is the equivalent size and payload to that robot. So we don't know whether the future will be robotised JCBs and diggers, or whether it will be using robots. So part of our work on the hub and through the Moby project you saw is to try and work out how accurate they are, how do you design for a robot assembly application. So